Voice clear? Fully audible? Thank you for the wishes. Clear. Okay, start. See, now, because of little oversighting last time in class 2 and 3, class 1 was only principle. Okay. Class 2, I took the example. This example I taken. In the question I have given something. Then, later, when you started, you interchange it. Actually, I only interchanged, but I asked you. Sometime when I looked there, see, the two numbers are here. Maybe this number I thought this one, so it was there. Number got interchanged. But it was a serious mistake. Mistake is not technical mistake. Principle correct. I told clearly this moment is this axis. I was moving the hand. So there is no question of technical mistake, first of all, will not happen. But it got interchanged. Then next class 3, last time, I stopped suddenly and went. Why? You told last class interchange. That is, you are responsible. When in the live class, you should observe, make a note. And if anything is when I wrote 30 there, you should have told me immediately, it is 45. You are not observing. See, those who come live, they should observe and tell those things. I moved my hand here. See, I told this is called MY. When I told this is MY is 45. I wrote 30 there. I thought this is this moment. Looking there, see, it may be written very close. Then, later in the class 3, I took once again this one only. I will tell you why. Because this is the major axis. This is a minor axis. Major axis, I applied little higher bending moment. Why? Stronger. So then on that day, it is interchanged. So therefore, and I told, if it is a Zoom class, okay, I can tell you correct it. But in YouTube, it will permanently remain. People will comment. He told in the question 45 here, later, where this couple is there, he wrote other way. I did not write other way. Observation mistake. So, this class I have to correct it now. So therefore, remember, class 2 and class 3, what all I explained holds good. I won't tell once again. Everything I told holds good. Every statement. Only thing is value changes. So what do you have to do? You start from class 4, note down the corrections now, and then restart and write fair copy for class 2 and class 3. And I will do one thing. Class 2, too many calculations. Class 4, small calculation. Where answer did not tally, I got annoyed and left the class suddenly. So I will see that correction comes to class 3 only. How? I will tell you now. See, make a note. Okay. Now make a note. Given question in, see, those who want class 2 and 3 to study, they should know, see, they should know there. I will give a small note there. In the description box in class 2 and 3, I will make note. For little correction, see class 4, then once again come back to class 2 and 3. Those who are serious, see. Given the question in class 2, which is further continued in class 3 also. Class 2 and 3, this question. Rectangular section 250 by 600. Anybody can tell this is 250, this is 600. Then axial compression 240 kilonewton. Then bending moments of 30 kN meter and 45 kN meter, 30 this way and 45 this way. This is how I gave the question. Yes or no? Tell me. In the beginning of class 2, this is how I gave the question. Yes or no? First. This is how I gave the question. Yes. Now, start. Question is, find resultant stress at CG of the cross section. Very simple. M1, Mx, My will not come because X is 0, Y is 0. Only P by A. There is no correction. CG of the cross section. Then, 4 random points P1, P2, P3, P4. I am not writing everything. Everything holds good as what I told in class 2. Distances are given there, note down. P1, P2, P3, P4. And also I continued P5, P6, P7, P8. This is P8 because 4 point randomly placed and another 4 point placed in the axis. P5 and P7 in x-x axis, P6 and P8 in y-y axis. Then I told, and lastly at 4 corners. These 4 corners is the most important. Most important is 4 corners. That is A, B, C, D. I hope A, B, C, D is not interchange. Okay. See, now you have to make a note. See, those who are serious should make a note. I repeatedly told, see here, you make a note, I am rubbing it now. I repeatedly told, if this is the cross section, if this is y-y axis, if this is x-x axis, actually red color required, okay, red is not required. Okay, red is there, I use the red color. Red is available. If this is y-y axis, this is x-x axis, I repeatedly told, when moment, BM or moment, anything you tell, this is about this axis, see. Whereas this moment, this way or this way, see, about this axis, see here, axis should come, moment should start from one side, it will overtake or what, go cross the axis, not go along the axis. See, therefore, I clearly told you, very crystal clear I told you, see, this is x-x axis. Moment about x-axis about this axis. So, this is the moment about x-x axis. And when you take moment about x-x axis, this side, as per this sketch, this is compression, this is tension, I told you, and distance to be considered is this way, that is this distance. In the equation m by I equals sigma by y, that y is not this y. That y is distance from axis. Strength of materials y will be our real y. See, strength of material formula y is our real y. Whereas for y axis, see, this is the y axis. See here, y axis. Moment is or BM, anything this way. So this is the BM about y axis. Now this side is compression, this side is tension. This all I explained. And distance should be measured from the axis. Where here compression tension variation this way. Y distance here. Compression tension variation is this way. So here or here, y, strength of materials y, in the formula m by I equal to sigma by y, that y is x, y this way, I told. Then this I very clearly told. Okay, next I started the question. See, general equation sigma resultant anywhere equal to compression positive is plus P by A, that is because the load is acting here, axial force. Then I told, first consider the term where x distance is there. Why? Usually analytical geometry write what? Ax plus by, that way. X term comes here. So this is your axis y. So consider this axis plus or minus BM about y axis divided by I about y axis. See, BM about y, see the hand here, divided by I about y into x distance, plus or minus BM about x axis divided by I about x axis, this is the axis, into y distance. Which y? This is not strength of materials y. This is what? Analytical geometry y, no sign for y. Whether it is upper side or lower side here, no negative positive because we want only distance. Why? Because sign we consider when you decide compression tension. If you write sign for y also, then also you can take. I will tell you, I won't tell that one. That is, it will be confusing for many people. Okay, this is a formula. Then, at that time, P I substituted correctly 240 10 to the power 3. No problem. And at that time, My, tell me, I told very clearly, this is My. Tell me My value. See here. Tell me here. What is My value? What is My value? First. What is My value? Where is my mobile? Here. What is My value? 45. Your My is 45 kilonewton meter. Board fully visible? Board visible or not? Or I have to make slightly down? I think slight down I have to make. Okay. Or because slightly not. Yes, fully visible now. Okay. My is 45 kilonewton meter. And Mx is how much? Tell me. What is Mx? Fast. Moment about Bm about x axis. This one. How much Mx? 10 to the power 6 I will write. This is kilonewton meter to Newton millimeter. It's not a problem. That we will consider. I am writing in what? Or I will do one thing. I substitute 240 kilonewton. But of course, in the equation, I put 240 10 to the power 3 by newtons I want. This is 30 kilonewton meter. As per what? This is, these two are this value and this value. This is as per given question. Given question. Okay. But, but right here. Unfortunately, remember, you only are responsible. Only are responsible because you are learning. I am teaching. If I, by mistake, if I put a wrong entry, it is called print mistake. But if you make the mistake, it is called technical mistake. See, I am very harsh. I can make mistake, no problem. So many times I make deliberate mistake that you will not be able to find out. That I will tell you afterwards. See, that is wrong. Sometime, occasionally, sometime it happens. Or in the college or class, sir. I will tell him. I will look at him and tell, keep quiet, don't talk. I know, he got the answer. Then I will tell him, I will signal him. Beda, Kannadadalli, hatra hogbittu, sundari. Hindi, chup raho. Means, yes, I am making deliberate mistakes. So many places. Suppose imagine, some places you have to multiply by 1.25 for some reason. Or you want to, you have to correct the value. I will enter the uncorrected value and proceed further. All will agree. Then I will warn them. Don't make this mistake again and again. Be careful. Remember it. In RCC, tell me, how many times you forgot factoring? Remember, in RCC, how many times you forgot factoring? Yes or no? Multiplying 1.5. You forgot so many times. Tell me yes or no? After repeated warning by me, telling again and again, see, it's a criminal mistake I will tell. And then still, I will deliberately will not factor. You also will not factor. When the time of answer comes, I will calculate the answer with the factored value. So, then someone will tell, sir, not coming. Then suddenly someone will tell, sir, factoring forgotten. Oh, remember, I did not forget because, see, my answer corresponds to that only. If so many times in the class I do one thing, I make one mistake deliberately. Later stages, when I take calculator in the class, some people will comment, oh, sir is doing some deliberate mistake. Otherwise, he will ask us, when he is taking calculator, means what? There is some trapping is there. But this is not that mistake. This is oversight. I looked here, I thought this is 45. So therefore, unfortunately, this is the correct one. See, this is the correct as per question. Correct as per question. But unfortunately, while substituting, we substituting in class number 2, not 3. In class number 2, in the mega class, we substituted, or rather, we means I and you together. See, you are responsible. We substituted. Tell me, my how much? Tell me. See there. You just now told my is 45. Tell me how much you substituted. Tell first. In class 2, see, this class, one class you are wasting because of this what? Because of no cooperation or not good response. We are wasting one class. But it is a good lesson for you. We substituted 30 kilonewton meter and substituted mx equal to 45 kilonewton meter. That is interchanged. Therefore, wrong values. Remember, wrong values. Therefore, the result we got in class 2 for P1, P2, P3, P4, P5, P6, P7, P8, then A, B, C, D at the end, A, B, C, D, 4 corners are all correct or wrong? Tell the answer. This is the given question. For this question, we substituted mx equal to 30, my equal to 45. Therefore, the result we got for P1, P2, P3, P4, P5, P6, P7, P8 and 4 corners in class number 2 is correct or wrong? Values. Technically correct. I never made mistake in x and y. Everything is correct. See, I never made mistake in x and y. That all you refer now. Class 2 is wrong. Therefore, result we got for all points. All how many points? CG 1, right? P1, P2, P3, P4, P5, P6, P7, 8. 1 plus 8 point actually plus 4 corner 4. 13 point. In those 13 point, apart from the CG of the cross section, where there x is 0, y is 0. Apart from that CG of cross section, all those 12 values are wrong. Remember, procedure is correct, but calculation part wrong. Now, what to do? In class 3, we took this value as once again correct. See, tell me. Now, in class 3, we once again took, how much, tell me, how much my you took in class 3? Tell me, in class 3, how much my you took? Class 2 gone. Class 3, how much my you took? How much my you took in class 3? 45. Therefore, answer we got in class 3 is correct or wrong? Answer we got in class 3 is correct or wrong? 4 corners only. Class 3 only corners. Where we took what? 45, 30. Class 2 you took 30 and 45. So answer we got in class 3 for the 4 corners correct. But that it will not tally the corner answer we got in class 2. Therefore, where corrections required now? Correction required for class 2 or class 3? Tell me. Correction required for class 2 or class 3? Correction required for class 2 or class 3? Correction is required for class 2. But if I correct class 2, it will be very, very huge. Why? 12 points you have to correct it. Yes or no? 12 points you have to correct it. Tell yes or no. Class 2, CG leave it. P1, P2, P3, P4, then P5, P6, P7, P8 and 4 corners. 12 point you have to change now. Tell yes or no. 12 point you have to change. Tell me yes or no. Class 2 we have to change for 12 points now. It will take another 1 hour. Once again, I would ask you, where is P1, where is P2, how much distance, all I would ask you. I would again write, tell me yes or no. If I correct for class 2, everything, I would once again ask you. No, you will do yourself. No, not that way. In my class, YouTube especially, I do not want mistake. No, you tell me yes or no. Correct, you will do yourself, correct, but it will be very 12 corrections. Tell me yes or no I want. I told yes or no. 12 corrections. I want yes or no. Yes. Class 3, how many corrections? Just one correction. Therefore, right here, you write all these things in your own words. After what all I told just now, write briefly. Therefore, what we will do is, I write here now. Therefore, see, therefore, what we will do is change the question. Change the question. Change the question. Therefore, after everything, now change the question. Change the question. That is only sketch. Only the sketch given in class 2. Given in class 2. Class 2, which was initially like this. Sorry. Which was initially this way given. This way given. Change it to. I told 45 here. Make it 30 kilonewton meter. I will round off. Make it 45 kN meter. In the question, see, when you make a fair copy, change it to 30 and 45. Clear this way now? Clear or not? First, change the question. First, clear or not? This question you change. See, I told BMs of so and so as given in the question. Sketch. Don't write this sketch. Write this sketch. You make fair copy. Now go to class 2 and change everything. Clear? Okay. Then tell me. If I change the question this way, then tell me. Then after change, tell what is my first. See there. My is like this only. My is like this only. See. My is like this. Tell what is my first. What is my? If you use this sketch, not that sketch, this sketch is cancelled. Cancelled and new sketch given here. New sketch. What is my now? Tell me. What is my? My will be 30 kilonewton meter and mx equal to how much? Mx equal to first. Mx equal to first. Mx equal to 45 kilonewton meter. Then your resultant stress anywhere with the compression positive becomes what? Plus P by A 240 10 to the power 3 divided by area is 150000 P by A over then plus or minus M about Y is 30 10 to the power 6 divided by I about YY is 4500. This all over 00 10 to the power 6 My by see M about Y. Tell me M about Y by I about Y into this distance. Tell me what distance? Into what distance now? X or Y? M about Y by I about Y into what distance? See, this from this axis into what distance? From this axis into what distance? Into X distance into x and plus or minus m about x. How much? 45 10 to the power 6 divided by I about x axis 781.25 10 to the power 6 m about xx into y. This is the formula. Or this will become what? This will become, okay, now if you simplify now, it will become 240 10 to the power 3 by 150000 equal to plus 1.6 plus or minus 30 divided by 4500. In the factor form, it is 1 by 150 times 1 by 150 times what? 1 by 150 times 1 by 150 times x and then plus or minus 45 by 781.25 reciprocal. 36 by 625 times y. Tell me yes or no. This is the equation for stress at any point. Compression positive. Just tell me correct or not. Fast. Correct or not I want. You are not answering. Correct or not? You will get this way. Fast. Tell me correct or not. You are tell correct or not now. Either correct. Or, oh, you can write. Oh, Udgara. Oh, this way right here. Oh. That only we wrote there. We wrote there and what? And solve the problem. Solve the problem. Because by that time data interchange while substituting. Now question interchange. In the question interchange. Therefore, now correct. Therefore, all the answer we got in class number 2 now will become what? Now will become all the answer we got in class number 2 will now become what? Will now become what? Class number 2, whatever you got now, you have to change the solution there. Everything is same, not much. What result we got in class number 2 is now is fully correct, will become correct. Okay. But remember, result in class 3 will be what? Result in class 3 will be what? First, result in class 3, I took this as 45, original value. See, result class 3, I took the original question. Result in class 3 is what? Not correct. It is not correct. Not correct. Therefore, you make a note now. See, you should read class 3 once again. I told about Z concept all. That all you have to study once again. You need only correction for numerical, not correction for explanation. Remember. So, you should be careful in a paper right here. See, now, therefore, we will now correct class number 3. But before that, now we will correct class 3 as per revised question. As per revised question. The revised question is this one. This one. This is the revised question. I will put here. As per revised question, which is correctly fits to class 2. Why? I told the reason. Revised question. Now, and remember, and in class 3, we considered the most important. Which one? We considered what? Considered the most important. That is, which stress, tell me? Most important, which stress? That is stresses at the corners. At corners. Which is the most critical for design purpose. Stress at the corners. Since these are at the corners. And therefore, before we correct class 3, we will now write result from class 2. See how much trouble you are giving me. Imagine, see how much trouble you are giving me. This much do I require. See how much you are troubling me. We will first write result from class 2. Result from class 2, which is correct. Which now becomes correct. Now becomes correct. Correct because of the changed question. Stress, resultant stress at A, resultant stress at B, resultant C, resultant D. Tell the answer. B, C, D, D. Tell this 4 answer. Class 2 you have to tell. In class 2, the long back, you have given the answer. Tell the answer. 4 values first. Not class 3, which actually this value did not tally in class 4, class 3. Class 3 is correct. In class 3, these 4 values did not come. I got upset then. I got upset. I told in my class, in structural engineering means what? Not everywhere. In basic subject, engineering mechanics or strength of materials or structural analysis, etc., or finite element method, matrix method, all. If the answer is not tallying, I told I will stop teaching. See, I take some indeterminate structure, slope, consistent deformation method, strain energy method, column energy method, moment area, then slope deflection method, moment method, Carney's method, matrix method, or flexibility method, any method you take. I will take a question, solve. Every question should give same answer, not micro millimeter difference. In my class, no question has courage to give different answer in my class. No question got courage to give different in my class. Why? Because I am always correct. So answer is minus 7.6, minus 3.6, plus 10.8, and plus 6.8. And make a note here. This is the result we got at the end of class 2. This result we got where? At end of class 2, by using the equation sigma resultant equal to plus P by A plus or minus my by Iy into x plus or minus mx by ix into y. That is, use the basic equation. Basic equation. Okay, now, 1 minute. Now today, this value will come. Do you think the value will come today or not? What do you feel? Do you think today the value will come or not now? What is your idea? What do you think? Will it now come or not? Today will it come or not? What do you feel in my class? Or any chance of mistake? Then if it is a mistake, I will stop the course. Any chance of getting wrong value today? Why? Today's class, will it come or not now? In the beginning only, it will come. Not it will come. It should come. See, ಕನ್ನಡದಲ್ಲಿ ಬರಲೇಬೇಕು, ಆನಾ ಹಿ ಚಾಹಿಯೆ. I told it should come. It is no question can escape. Or now write a small note. See, I will maintain this one. This I will remove. Okay. So now, see, remember, just see how much trouble you gave me now. Now see, now, last time class 3 is cancelled. Class 3 is cancelled. Remember, cancelled only for numerical. Only for some numerical. Not concept. Only for some numerical. Whereas Whereas all explanation is still valid. It is permanently valid. That is what? Since we want only corner pressure, we want resultant stress only at corners, we can use, tell what? We can use what? Need not use m by I into y. What you can use? Tell me. We can use what? Not m by I into y. What you can use? Since you want only corner, we can use. First. We can use Z concept. We can use Z concept. Why? Because, see, Z concept is only for extreme fibers, extreme fiber stress, and corners are also extreme fiber. Therefore, use Z concept. Okay. Then also note, when we go for footing, that is pressure calculation, there also we want only corner. Therefore, there also we are using Z concept. That is, tomorrow's class is a concluding class where I will tell you footing pressure, and also I will tell you about middle third rule and one kern or core distance, all technical points. Tomorrow I will conclude. Okay, now go to that concept. Now, regarding that concept, full explanation given in class number 3. Go through it. Full explanation given in class number 3. Go through it. Okay, then I will write here. See, I will all remove now. Then, see, now I will put a rectangle here, this way. Then, A, B, C, D. Red color. Color problem, too much. Some of the pens, there is no ink. I have to put the ink now. This is your x-x axis. This is your y-y axis. Later, this x-x is going to be 1, 1, y-y is going to be 2, 2 in the next class. Okay, now, this is axis. See, now, we want only corner pressure. These two distances are, this full distance is 250 millimeter. These two are 125 and 125. This full distance is 600 millimeter. Therefore, these two are each 300. And then the resultant stress at any corner, remember, only corner. You cannot take a random point here. At 4 corners is given by sigma resultant at any corner equal to, see, plus compression positive plus P by A plus or minus, see, these all I explained for you. I will remove this one now here. See, my divided by Iy into x. My by Iy into x, this way. Now, your x will become maximum, or tell me, x will become maximum. That is, this x will become maximum, or my divided by zy plus or minus my divided by z about yy, where z about yy is I about yy divided by, see, I about yy divided by from the yy extreme distance, maximum maximum by 2 distance to extreme fiber with respect to y axis. Tell the answer. This is already told last time. Actually, I'm wasting time. Tell the answer. With respect to y extreme fiber distance, how much? How much? Extreme fiber distance, how much here? 300. This is one option. Or directly you can write what? BD square by 6. B is the side parallel to YY. How much? Tell me. B is the side parallel to YY. How much? Tell me answer. Or you can use directly BD square by 6. This will come to tomorrow once again. What is B? B equal to 300. Tell me D equal to. From the YY, parallel side is 300. Ayo. B is your old answer. B is 250. D equal to 600. Tell the answer. What is Z about YY? Tell the answer. What is Z about Y? Answer. You can do one thing. You can either write IYY equal to, how much answer you got? I forgot IYY. IYY is 4,500 10 to the power 6 divided by what? Y max of about 300. Or you can use directly, that is nothing but BD cube by 12 divided by D by 2 is BD square by 6. You got? Don't give wrong answer now. How much? Answer. How much Z will come? How much Z will come? Anyway, this will be explained once again tomorrow because foundation case. The very purpose of this problem is for footing. Otherwise not required. So 15 10 to the power 6. That is Z about YY. Same spirit. Z about then when you write M about X by IXX into Y, then that Y maximum you require. That, or you can write M about X by I about X by Y maximum. Then IX is, what is the IX value? Anybody remember IX value? I forgot. I think I had to calculate. See, IXX value, how much you got? Anybody can tell what is IXX value? Anybody can tell what is the IXX value? That is 600 into 250 cube by 12. 600 into 250 cube by 12. IXX. Tell the IXX value. You got it already last time. Or calculate now. My calculator is there. I have got pens and calculator to hold here. 781.25. Y max is from XX axis. Y max is 125. Or you can use Z about X equal directly BD square by 6 only. Don't tell DB square. B is the side which is parallel to XX axis. So here your B will be 600 and D will be 250. Okay, in both the cases, tell the answer ZXX. Both will give same answer for you. ZXX. How much ZXX? ZXX. Directly 600, 6.25. Okay. 6.25 10 to the power 6 millimeter cube. Okay. This is what I had done last time. Last time this was explained. Last time what happened is where mx comes, we substituted my value. Where my comes, we substitute mx value as per the revised question. Or if the question is not changed, class number 3 is correct. Big mistake in class number 2. Mega mistake. To minimize the time, I decided to correct class number 2. Why? So that 3 is a small correction. Therefore, with all this correction, see, therefore, right, resultant stress at any corner, compression positive equal to What is the formula? Formula is, I wrote already, plus P by A plus M about Y by Z about Y plus Z about Y plus or minus M about X by Z about X. You know, M by I into Y, but here M by Z over. Or if you substitute, P is, it is plus 240 10 to the power 3 divided by area is 150000 plus or minus M about Y. How much? Now as per the correction, tell me M about Y, how much? Now you do be careful, don't give last time answer. This is the mistake last time. Tell me M about Y. After the question is corrected, how much? M about Y after the question is corrected. What is M about Y? After the question is corrected. 30 or 45? M about Y. After the question is corrected. 30 plus or minus 30 10 to the power 6 divided by Z about YY is, any answer? 1.5 10 to the power 6. What is this one? 15 I do. 15. Okay. 15 10 to the power 6. Then plus or minus M about X is 45 10 to the power 6 divided by Z about XX is 6.25 10 to the power 6. Or you can tell sigma at any corner, compression positive is, tell the answer, 240 10 to the power 3 divided by 15,000. Answer. One and now X and Y will not come. Why? X and Y, when you take M by Z concept, XY will not come because it is already accounted in the Z, first number. Plus 1.6, correct? Plus or minus this number, first. This number. Second number. 1.6 or 1.5, 1.6. Second number. Plus or minus, second number. 2. Only 2. Again. Plus or minus last number. 45 by 6.25. 45 by 6.25. 7.2 is the answer. Okay. Therefore, now see, last information for you. I will not tell once again. See, this is due to what? Tell me. This is due to what? My or mx? Remember, this is due to what? My or mx? Remember, this is due to my or mx. This 2 is due to what? My. This is due to mx or my is like this. See, this is the y axis. My is like this. My is like this. This is A, this is B, this is C, this is D. Therefore, for My, this side is compression, this side is tension. Therefore, when you substitute now you want, same way, I want Mx. When I want Mx, this term, Xx axis is here, Xx. Your moment Mx is like this, Mx. This is compression. This is tension. Therefore, remember, when you use this term, I have a hint for you. A, B, C, D. Here also, for this term. Now you do it. This is A, B, C, D. Tell the answer. When I use 2, which are positive? When I use this term due to My, see, tell me, where positive? First. When I use the 2, plus or minus, which point I have to use positive, which point I have to use negative? See the diagram here. My is like this. Next class I will give more clarity. I will B and C positive, B positive, C positive. Whereas A and D tension, A negative, this is positive, D negative, over. Now tell me, When I use mx, ABCD, ABCD. When I use mx, tell me which two corners positive. When I use mx, which two corner positive? C and D, these two. C positive, D positive, A negative, and B negative. Therefore, when I find at A, what you do? Therefore, sigma resultant at A, sigma resultant at B, sigma resultant at C, sigma at D is plus, 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 plus. This term is plus at D and C, whereas this term is minus here. For when I use the last term, it is plus at C and sorry, your confusion. Okay, when I use this one, plus at B and C, plus plus second term, and minus at A and D. When I use the last term here, it is plus at C and D, minus at A and B. You should get the same answer. Calculate all the four values. I will take a small break. I will tell it has to come minus 7. These four values you got last should repeat. Otherwise, from right today, don't come to any of my class. Check fast. Check fast. Write the answer once again. Correctly write. You should get what? Answer. In the same order, minus 7.6 Newton per mm square, then minus 3.6 plus 10.8 plus 6.8. Then you should write minus 7.6 means tension of 7.6. Minus 3.6 means tensile 3.6. Plus 10.8 means compression 10.8. Plus 6.8 means compression 6.8. That much you have to do it. Check fast. I'll take, check fast, coming or not coming, comment there. I'll take 5 minutes break for non-stop talking. See, today's 1 hour actually wasted. If the mistake is not made, last time only would have got this answer. Last time answer, we would have got it now. Okay, fast comment. Is it coming same answer or not? Then make a neat fair copy of the solution of the question in a book. There don't write mistake solve. You change the question and solve. Clear? Don't write what happened in the YouTube class. You make a note. If I refer YouTube class, some interchanging is there which is corrected in class number 5. You write that way. 5 or 4. Class number 4. Therefore, you make a fair copy of the solution. Okay. Fast comment. You have to comment now. Answer coming or not coming. If you type coming answer, I will continue. 5 minutes break. You have to type first. Answer coming or not coming. I love that one. Go to new one now. You told answer is tally. Answer has to tally. There is no chance of answer not tally. Next to what I require, because the inequality is not good. That's one problem. The inequality sometimes becomes little, I don't know why. Once in a while, that inequality gives trouble. So wait for 1 minute, 5 minutes, 2 minutes. Or average, 1, 2 and 5, total average. I am already 7 by 300. 2.67 minutes. Okay. Now, I will do one thing now. I will go to an I section problem. I section problem where it is required in case of T structures. So therefore, I will go for I section problem. Question I will write. Then some extra information I will give you about converting. That tomorrow I will take up. Okay. Voice clear? Voice clear or not? First. Voice clear? First tell me, is the voice clear? Clear, okay. Now see, next question. Next question. A column, very important, short column. If it is a long column, I told you corrections required in RCC or steel. A short column is of I section 200 millimeter by 500 millimeter. Flanges are 16 mm thick, and web is 10 mm thick. This is ISMB maybe 500. If it is ISMB 500, web thickness is 9 point something or 10.2 I think. But the flange thickness is not 16. ISMB 500, flange thickness is 17 point something I think. Okay, this is not. So remember, if you are using rolled I section, moment of inertia you get directly from steel table. You don't have to calculate. This is 10th of problem. It is subjected to means the cross section. It is the cross section. Cross section is subjected to a compressive load or vertical axial load, compression in nature, axial load of around 400 kilonewton, which is eccentric. Remember, which is eccentric. How means as shown in figure. That is see, I'll put a three-dimensional sketch here. This is the column. 3D sketch. Column goes this way. This is the I section column. You can see thickness all here. This line you can see here. This line you can see here. Okay, now here the load is acting not axial. It is eccentric. Means, see, where it can act anywhere. It can act outside also. Why? There will be a plate above this one. The load is acting here, somewhere here. How much load? The load is acting somewhere here. In the plane, 1 minute here, I'll show the plane for you. See, this is the plane of the I section. The load is acting somewhere here. How much? 400 kilonewton. Where means, see, it is acting this way, the load position from here. This way it is acting at 100 millimeter. And this way it is acting at this way. See, the point this way is 120 millimeter. This is 120 millimeter. This way it is acting at 200, say 65 millimeter. 65 millimeter. That is, see, I will tell you, the column is like this. Load is acting somewhere here. See, this is the column, not here. Some will tell, sir, how? Above the column there will be a plate. In the plate it is acting. That all you don't bother. Now, find resultant stresses. Now onwards, we don't waste time by finding here. That you can do always. Why? M by I into Y. That is not required. Resultant stresses at 4 corners. These 4 corners, see, 4 corners, A, B, C, D. A here, anywhere. B, I don't think A, I'll put A here. A here, B here, C here, D here. Is the question clear? First tell me. Is the question clear? If clear, I'll go to the next part. If the question is clear, I'll go to the next sketch. Clear? No, that is the voice clear. You have to write question clear. Yes. Now, what you do is, first forget it. See, column is like this here. See. Now, axis problem is your problem. Now, this column straighten here. You write from top. This way is inclined. You cannot see it. It is actually it is like this only. It is like this only. Little incline shown. Or you turn it. No problem. When you turn it, cross section will become like this. See, red color better. When you turn, see, axis is your problem. Axis is your problem. See, you turn it here. Your cross section will be like this. Actually, no, it is a rolled steel. It is not rolled steel. It is a welded I section. Okay, this is the cross section. It's a cross section. It is not. Okay, here actually, see this side. Write a note here. This is a joist, but here we take rectangles only. Why? Because property is not given. This is a cross section. This is how much. See, I have deliberately turned XX to YY now. Don't bother about it. This is 200 millimeter. This is what? 500 millimeter. This thickness and this thickness are 16. Therefore, anybody can tell what is this distance fast. Total depth is 500. What is this distance? Fast. This is 16. What is this distance? That you require half an hour time. .468 millimeter. Turning is your choice. 468 calculated. And this thickness is what? Web thickness is 10 millimeter. 10 na? 10. Now, first you get sectional properties. What you do is, you do not bother. See, if you see steel table, this is XX, this is YY. Here, that is not required for us. You write, as per the sketch, this is XX. Why? We are not in steel. Actually, this XX is YY in steel table. Don't bother about it now. This is strength of materials. This is YY. Okay, start. First you require cross-sectional properties. I want area of the section, moment of inertia about the x-x axis, and I about, first I want, okay, I about x-x axis and I about y-y axis. Remember, when you find moment of inertia, I-y-y, you should do like I-x-x I explained for I section. When I do I about x-x, it is equal to I-y-y in usual calculation. Clear or not? Deliberately I given this way. When you do moment of inertia, see, you know some shortcut all for this I section. See, this way. How you find x-x, that way you have to find y-y here. Clear or not? First. Tell me clear or not? Clear. Okay. I will do one thing now. Moment of inertia, I am not explaining. I got better work to do. So I will tell you area equal to 200 into 16 into 2 plus 468 into 10. Area will be 11080 mm square. Anybody who is general public, if you ask, sir, how to find area, means don't come to my class. And if they ask how to find moment of inertia, already explained for you. In the YouTube only explained. But my duty is not moment of inertia now. For the course BSK, I explained. I about XX. I about YY I will first do. I will first do I about XX. IXX will be 21.3723 or 372 sufficient. 372 10 to the power 6 millimeter power 4. Tell me, anybody getting the answer? Check the answer. IY, check the answer. IYY. IYY will be 460.365 10 to the power 6 millimeter power 4. This is your problem. This is your headache. This is your headache, not my headache. Anybody got the answer? Tell first. Anybody got? Area IXX and IYY. This XX is usual YY for what? I section. This YY is, if you want, you can turn and find, again turn it. Don't do it. Okay. Suppose by chance answer is wrong. You confirm it. Anyway, because why? In case answer is not coming, you change and tell me, you tell answer is different. Okay. If any mistake is there here, it is not technical mistake. It is a calculator problem, not my problem. Okay. This is the cross section. Now, see, further steps. Concepts are important now. Okay, now, we want, see, write a note here. I am dictating. In the previous question, P, My and Mx are given. But this question, My, Mx are not given. P only given. Tell me, you should write. Is the given, you should write all these things. Is that given P is axial force or eccentric force? Axially, is that P is axial force with respect to cross section or eccentric force? Is it purely passing to axis through CG? Is it axial or eccentric? That whatever given that P, eccentric. So you should replace it by axial force P with biaxial bending. Okay, 1 minute. See, I will explain here. How? See now. Now, write one more sketch. This all I can remove. I can write here. See. Write the cross section once again here. Now, you need not consider flange web ball. This is the I section. See. This is the what axis? YY axis. This is XX axis. This is a plan. In the plan, load is acting perpendicular. See, the load is acting here. Which quadrant? It is acting somewhere here. This is where P is acting. See, this distance is, how much I told? It is 500 means 250 millimeter. Whereas in the question they told this distance as how much? 120 millimeter. Therefore, anybody tell what is this distance? Fast. Calculate the distance. Red color I am using. 250 given, 120 here. This is 130 millimeter. And also, this distance is, it is 200 means 100 millimeter. And the load is given at how much? From here, 65 millimeter. Therefore, tell what is this distance? Fast. This distance, 165 is 35 millimeter. Now, this is the P. This is the cross section. Tell me fast, clear or not clear? You should tell immediately clear or not clear. This is the what? This is the load acting where? In the cross section, perpendicular to cross section. Clear or not clear? First. Clear. Now, you should tell it, or that is, you replace that eccentric load by what? Axial force with biaxial BM as given here, as shown here, or as shown below, or somewhere where I am showing, as shown wherever he is showing, right that way, as shown wherever he is showing. Okay, I will show here. See, I will put once again the sketch. All this concept clear means you will be learning subject thoroughly. Out of scale, okay. Little out of scale, no problem. Little smaller, okay, done. Or little bigger, I'll make it. Otherwise, because there is 500. Okay, that is not a problem. This way. See now correctly what I am doing. This is your XX axis. XX, YY, some will tell, sir, it is actually YY in steel. This subject is not steel. YY. This load here, replace here. It will become P here. So that P equal to how much? How much I told? Where I told? P. Where is the question? 400 kilonewton. 400 kilonewton, or now only 400 10 to the power 3 Newton. Thank you. Over. Now, see, the load is acting here. So about YY, it will create a moment like this. See, this way. A moment this way about YY, that is M about YY. See here. If the load is here about YY, it will create a moment like this of how much? My equal to that whatever P into, tell the number, into how much? If it is clear, tell the number. Those who are my regular students, if they understand, sufficient for me. Those who are regular, if they understand. Others, they should manage. Whatever that P into 130, or P equal to 400 10 to the power 3 Newton into 130, or this will be equal to, tell in Newton millimeter. Tell the answer in Newton millimeter. 10 to the power 6 I want. I want answer in 10 to the power 6. What is the number? I want answer in 10 to the power 6. 400 10 to the power 3 into 130. Tell in 10 to the power 6 answer. 52. 52 Newton millimeter. And this P is eccentric. These all you have to write. If you want to understand, you should write. I am not writing why. This class is not for enjoyment or what time pass. Those who are serious, what all I tell, they should write. It will also create bending about x axis. See, axis is here, load is here. About x axis, it will create a BM this way. Only this way. This way it will create. That is M about x equal to whatever is P into tell distance. Whatever is P tell distance into whatever is P into distance 35 into 35 or equal to 400 10 to the power 3 into 35. Tell this also in 10 to the power 6 Newton millimeter. Fast. This corner is A, this corner is A, this corner is B, this corner is C, this corner is D. Now you can solve the question very easily. Answer 14 10 to the power 6 over. Now result since we want resultant stress only at corners, use Z concept. Tell the answer. Z about YY equal to I about YY divided by, tell the answer. Z about YY equal to, see the hand here. Z about YY equal to I about YY divided by extreme fiber distance. Extreme fiber distance from YY. Tell how much? Equal to Z. Now you cannot use BD square by 6 now. Why? It is not rectangle. Tell the answer. Z about YY equal to I about YY into I divide by extreme fiber distance from YY. How much? See the sketch there. See any sketch there. See one sketch here. You can write one more sketch here. Or you can see here now. Either side. Into distance. Either that end or this end. How much answer? Z about YY. I about YY by how much? Distance. I have not written here. If this is 250, this is also 250. 100. I by Y. What is Y maximum? Tell fast. What is Y maximum? 250. Start. Tell the answer. Tell the answer in 10 to the power 6 millimeter cube. Substitute. IYY is here. 460.365 divided by 250. Answer fast. 460.365 divided by 250. 450.365 divided by 250. Answer. Little more accurate. 4 decimals or third decimal will do. This much time. 1.841. Okay. Same way, Z about x-axis equal to I about x-axis divided by extreme fiber distance from x-axis. Tell the answer. From x-axis, either that side or this side, from x-axis, extreme fiber distance. See, this bending theory is understand is nothing. How much? Extreme fiber distance from x-axis. It is not 250 now. How much? Fast. Extreme fiber distance from x-axis. 100. Therefore, answer. How much? Answer is IYY is 21.372 divided by 100 is 0.214. Correct? 0.214. Third decimal. 0.2137. Okay. 0.2137 into 10 to the power 6 millimeter power 3. Tell me, fully clear means I will close the class now. I will tell you why. If it is fully clear, I will close the class. You give the answer next time. Fully clear means I will close the class. You give the answer next time. Okay, now see. Therefore, finally, see how simple it is now. Only thing is, you cannot find Z by BD square by 6. You have to find I and by Y maximum. Therefore, see, sigma resultant at any corner equal to plus P by A plus or minus My by IY, My by Z about Y plus or minus mx by z about x equal to plus P is 400 10 to the power 3 divided by area is 11080 plus or minus m about yy is 52 10 to the power 6 divided by z about yy is 1.841 10 to the power 6 time plus or minus plus or minus m about x is 14 10 to the power 6 divided by z about x is 0.2137 10 to the power 6 or it will become equal to, I will calculate because you are wasting a lot of time. I will calculate 400 10 to the power 3 divided by 11080 is 36.101. It is plus 36.101 plus or minus 52 divided by 1.841. 28.246 again plus or minus 14 divided by 0.2137. 65.512. This is the expression for resultant test. Now, so simple. See now. Remember, this is due to my. This is due to mx. Now, how is my? How is mx? How is mx here? Yy is here and my is like this. Therefore, due to my, here compression, here also compression, here tension, here tension. Therefore, use plus sign here, minus sign here. For the first term. For which term? This is for this one. And for this one, your x-axis is here. This is already known for you. Mx is like this. Therefore, here compression, here also compression, here tension, here also tension. Use plus sign here, use plus sign here, use minus sign here, use minus sign here. Tell me, now can you calculate or do you want me to calculate and write the answer or leave the question? Tell the answer. Now 4 corner, remember A, remember this is A, this is B, this is C, this is D. Can you type the answer in the next class so that I will write on the board? When I start the next class, you give the answer for 4 corner in the order. Now tell me, shall I calculate now or stop or mind my own business? What shall I do? Shall I conclude the class or calculate and enter now? Next time I will tell you, the result is so and so. Some will tell which question? Which question? Don't come to my class. See, I tell that way. You should continuously come to the class, not come suddenly one class and tell what is this one? Nothing. Okay. Now you do it and type the answer. So next time, don't give wrong answer. So the concept of, see, now this question is equal to last time question. Last time question directly P, My, Mx given. This question Mx, My you calculated. Now I will give next time some question where P is eccentric and also Mx, My are there. Then you have to add the values. So there also I will take on I section. Clear now? Okay. We'll conclude the class. We'll continue tomorrow.